All right. Let's hear it for my brother, Damon Evans, Agile Project Manager and Hardware Hacker Extraordinaire and Test Pilot.
Thanks very much, everybody. And let's give a hand for my brother, Ron Evans, old school code slinger and Ruby expert.
So, a lot of you know about this. This is probably the most famous airship in history, and don't be afraid, we are not using that much hydrogen today. So, only the first 8 rows or so have to worry.
And one thing that a lot of people don't realize about the Hindenburg is that even though it's such a hugely publicized disaster, of the 100 people that were on board, two-thirds of them actually survived the crash. So it wasn't quite as fatal as you'd expect. Considering.
What's amazing is it was actually only the last step in a tragic series of accidents which affected every country which had a fleet of airships. Germany was only the last country standing. The United States, Britain, Italy, and France had also lost their entire fleets of airships. This is the USS Shenandoah, which was the pride of the American fleet in an earlier time before the Hindenburg disaster.
The Americans also had the USS Macon, which was not only an airship, but also an aircraft carrier that had within it a couple of dozen biplanes that landed on like a trapeze that had pulled up. Wow.
That sounds safe. But that was the end of airships for nearly half a century until recently when newer technologies have come together to create a whole new generation of flying vehicles.
This particular airship is known as the Skycat, and what it has, it's not just a traditional airship, it's actually a hybrid lift airship. The shape of the body creates like a lifting body shape, like a wing, so that it uses forward thrust to give additional lift above and beyond what the gas provides, which makes it a lot more maneuverable and less susceptible to the kinds of storms that destroyed the previous round of airships.
So unmanned aerial vehicles are something that we've seen a lot of. This Predator drone is probably flying over Afghanistan even as we speak. But let's change the subject a little tiny bit. Open source hardware. Who here knows what open source hardware is? Oh yeah, well for those very few people who don't, open source hardware takes the same concepts as open source software, but it applies it to the hardware world. So publishing the schematics, the parts lists, diagrams, plans, and everything else you need to build a hardware device, the same as publicizing your open source software project. This is an Arduino, which is probably the most popular and well-known open source hardware device.
The Arduino Decimilla there was only one of a bunch of different processors that can run the Arduino setup. It's part of the workhorse by situation.
But what's interesting is it's not just a hardware, but it's also a software package which combines together to let non-programmers do interesting things with hardware. This is an exhibit by artist Jody Zellin, who's a Los Angeles-based artist who built this installation with the help of LA Collective Machine Project. So there's some pretty interesting things going on with open source hardware. But what we're interested in is what these two characters are up to. This is Jordi Muñez and Chris Anderson. Chris is very well known as the editor-in-chief of Wired magazine and also the author of Free, which is a very cool, interesting new book that's come out.
This photo was taken just after they won a competition in Colorado in front of the Sparkfront Electronics building. The contest was to see who could have their robotic autonomous vehicle circle the building. Chris and Jordi were the only aerial entries, so they had a bit of an edge, even though I believe their plane ended up in a tree in one of the passes.
Yeah, the second run, it took a few hours to call the fire department and get it down. And then last, but absolutely not least, a man that many of you may know, Greg Bornstein, who is the creator of Ruby Arduino development, which allows you to use Ruby to program your Arduino microcontrollers. So we saw all these things going on and thought, wow, what if we could combine the prolific coders of the Ruby community along with the open source unmanned aerial vehicle community? Then we would really have something. So in March of this year, we started Project Flying Robot, basically to combine these two elements. So why did we do this? Well, yes, as brothers, we've been trying to build flying vehicles since we were kids. In fact, he tried to launch himself off my parents' roof when he was 9.
It would have worked if you had to stop me.
Well, you know, Mom wouldn't have liked that. But it turned out that it was a lot harder to do hardware development than we thought.
One of the Great things that we like about working with hardware is it forces you to think outside the box. It forces you to come right to terms with the difference between how things should work versus how they actually do work, which makes the applying the principles of agile development that much more important. And of course, there's a few differences in how we have to apply them.
But we found out very quickly if we didn't do that, we would get in some pretty serious trouble. But things are a lot different. For example, test-driven development. Or integration testing. Personal favorite of mine, design patterns.
And version control. I think you guys know.
And, of course, pair programming. In our case, though, we discovered that blaming the other guy was not really going to help you if you said, oh, it's because my brother forgot to wire the circuit correctly.
Or if I say it's because my brother didn't take gearing ratios of servo motors into account in his code.
You had to mention that. So let's take a look at the big picture here of exactly what is Flying Robot. It's a combination of plugins for Ruby Arduino development, which already provide support for most of the hardware devices that you would need in order to build an unmanned aerial vehicle.
Hardware like motor controllers that run your motors, rangefinders, iris sensors, GPS, and a whole suite of other sensors you can throw in.
Then beyond that, we use wireless radio frequency modems from XB to have a serial protocol that we call Flying Robot, a very simple serial control protocol to control the elevators, ailerons, throttle, all of the different controls that you have in your flying vehicle. And then last but not least, your ground control system. The ground control system that Damon was using earlier was actually a custom hardware device that we built called Norris, which combines a WeChuck along with what we call Houston, which is a hardware device. So when you get Chuck and Houston, obviously it's Norris. And in this case, though, we also can use other kinds of systems. For example, software. So let's go to some actual more demo stuff. That's always fun. So first of all, let's see, where's my window? Here we go. Who knows about shoes, Ruby shoes? I just want to take a moment of silence for someone who has departed from our community. We don't know where Y is, but Y, we miss you. We hope you come back, and we're sending a search party airborne style. So let's take a little look-see here. We're going to launch a program that we call Mercury, as in winged shoes. So let's see here. This is another blimp that we built. We support a variety of different Arduino-based aerial vehicle platforms. The custom blimp that you saw before was kind of a high-powered vehicle. This is actually a kit that you can buy from either Makershed or DIY Drones called the Blimpduino. And it is kind of a standard reference platform for a lot of their aerial vehicles based on the Arduino. And so it combines a couple of interesting elements. It does have some sensors in there. And so we're going to use this application here. We're going to connect to it.
And if you're wondering what I'm doing, having neutral buoyancy is really important to have these things fly properly. And Lego bricks are a convenient way to add a few grams at a time.
All right, so here we see the compass. We have a Honeywell digital compass that's built in. That's actually refreshing. We're showing our battery voltage, which is shockingly low. That's kind of scary. One thing about lithium polymer batteries is they're very fragile. If you go below the minimum threshold for voltage, you can basically throw them out.
We have killed more than a couple of rather expensive batteries.
Yeah, I kill them at a shocking rate.
Also, if you overvolt them, they have the possibility to, explode. So all that to be aware of.
Well, I just realized we need our infrared beacon. Do you have the beacon? I'll hold the blimp. You get the beacon. We're actually going to demonstrate right now some of our autopilot routines that we've written. We're going to show two different things. One is we're going to show an infrared beacon, something similar to what you would see in a laser tag game. The infrared sensors in here, we have a little matrix array that's going to read the readings, and it will turn the blimp to face towards the beacon. If we can find the beacon. Well, in the meantime, let's show the other one. We're going to show it basically try and point itself towards north. Or do we need more ballast first? Yeah, it's leaving. This one's a lot lighter because it uses a printed circuit board. That's a little too heavy.
Oh, that's why. Take off.
Take the whole thing apart eventually. Something will happen.
Some point, something will be there.
Hey, good enough.
Cool.
All right. Well, let's hit the status and see where it's actually at. It's still above 6 volts. It's pretty marginal.
I think that we'll switch batteries.
It's close enough. All right, so let's turn on Autopilot 2. Contact. So it's a little oddly ballasted.
Tricky to get it exactly where you need it to be.
Any more marbles in there?
A lot of marbles. I've lost my marbles.
It's amazing what you can do with Lego parts, though. Especially when you just sort of fling them in there.
That's sort of my goal at this point.
It looks pretty good, though.
Not so bad. I'll just think that we fly away from us. There we go. We need a little more thruster if these things are going to go.
The thrust is on.
Yeah, I think we're having trouble with this particular one. But you can see the readout of the sensors. There was a different motor loadout. Some of the motors behave a little differently under different power circumstances, so there's probably just the autopilot routine didn't have enough power to drive these particular motors.
That's why, oh, by the way, let me interrupt you 1 second. In case you're wondering why it's so incredibly hot in here, we have very weak motors, so even the slightest perceptible breeze will cause us to completely lose control over this vehicle.
Oh.
So we will
turns
turn
are
on
not your
air
friend.
conditioning at maximum power immediately after this session. All right, so did you find the beacon?
I did not find the
Did not find the beacon. Well,
I think we're going right to live program.
we're going right to the in-flight programming part of our demo. We're going to actually break several rules here today. We're going to both do live coding and live coding of a flying object. All right, let's do this, people. So, flying robot is a gem. Yes, gem cutter, gem. Woo. And it is available now. We're on actually the 4th version, 0.004, because, well, all flying vehicles are inherently prototypes. So the first thing you do when you're going to create a new project is we'll go to a directory where we're not going to make a mess. And we say rad. Can you see this? Rad is Ruby Arduino development. It's a command that will create a new project. So we'll say rad Ruby blimp.
Can you shrink the window a little bit so the text is up a bit? Light background. Light back. Shrink the window.
I'm sorry, shrink the window?
Track forward. Yeah, I can drag it.
Oh, yeah, okay. Well, everyone's got some advice here today. Unfortunately, I can't quite get to the bottom. Well, close enough. You'll see lots in a minute. All right, so we created a new RAD project. All right, so now we're going to take that project and we're going to turn it into a flying robot project. So we'll run the flying robot command. And right now it's adding all of the flying robot plugins, and it's going to actually modify the main sketch. And if you're not aware of it, a sketch is the name of a program that you run on an Arduino processor. Something similar to what we saw earlier during processing. In fact, the code is very, very similar. So we've done, and we've created the project, so let's go into it. And let's take a look at what we have created. Lots of my notes from before. Never mind that. All right, so we've actually gone and created a new project that implements all of the basic interface commands for flying robots. So we were talking about before the ability to hail to see if it's still alive, the status of its instruments, controlling its elevators, ailerons, which control whether you're angled to the left or the right, rudder, and throttle. So what we're going to do right now is we're actually going to implement a very, very simplistic version of the throttle. So first thing we're going to do is increase the baud rate used by our XB modems. And you're probably wondering, what the hell is this baud rate? Because not on purpose. How's that? Can you see me now? Good. All right, so Because the blimp Arduino board that we're using is actually running at half its normal speed, we have to increase the baud rate to double normal speed. So, by the way, we're only working with 14K of memory inside this thing. Not even 14 megs, 14K bytes, yes. So we've changed the baud rate. And now what we're going to do is we're going to actually implement the commands that we need. If I can find my card where I scribbled down my notes. So the first thing we need to do is we need to declare some output pins, which are actually going to turn on the voltage to the motor controller. So we'll say output pin 2, that corresponds to the right motor controller. All right, cool. So now we need to declare pin 3 for the right speed. Declare pin 4 for the left motor. And then pin 5 for the left motor speed. All right, now we've declared all of the things that we need. Now we're ready to actually turn on the throttle command. Oh, not yet. All right, so what we're going to do here is we're going to tell our right motor, that's a good idea, changing the battery, to send an L293 send command, which is L293 is a very common motor controller driver. And we're going to tell it to use the right speed to turn them on going forward at the current throttle speed that came in from our ground station. And then the same thing for the left. Oh, that would help, huh? All right, and then we need to change this to the left. And to tell the left motor. All right, at this point, we should have everything that we need to actually command the blimp. Now, we just need to upload this code wirelessly using our XB modem. So yes, we can do in-flight programming. So now if we say rake make upload, if we've done everything right, that is now uploading code wirelessly through the ether to the flying vehicle. I'll only do this once. And it reads back to the flash memory that's on the Arduino to verify that the correct byte codes were sent. Now, just a quick aside, we are not actually using Ruby. We're using Ruby as a domain-specific language. But we're actually then taking that and compiling it down into C++ and then into the AVR bytecode. Someday when the cool kids have actually written an AVR backend for LLVM, we'll run real Ruby on this. So guys working on that project, you know who you are. So now we're going to use the screen command to send simple serial commands to this thing and turn it on. So the first thing we got to do is hail it, make sure that it responds. Sorry. All right, so Roger, we hit status. It is operational. So now we're going to say throttle forward 40. Applause. Now we're going to turn the throttle off, which is something we forgot during our very first demo. Throttle forward 0.
The tether is a relatively recent innovation.
All right, so we have actually just programmed this thing wirelessly. We wrote a little bit of code to command it. We implemented a very rudimentary version of the throttle function. You kind of get the idea of where this goes. All right, very cool. Hardware time. So now we're going to take a little hardware walkthrough and see what actually made this happen.
Legos out of the way, and marbles and other forms of ballast. We're already transporting junk. All right, well, first I'm going to show you the Arduino hardware inside. It's a basic rundown. The first thing you'll notice is the vectoring servo. We have the motors on the side. The cool thing about with one servo and a couple of motors, we can use two inputs to actually get 3 degrees of motion by being able to go up and down by vectoring the servos, and then right and left by offsetting the power of the motors. Other thing to see is the lithium battery, which we've gone through way too many. Also, that's the XP modem there. Underneath that, see it, there's a marble. But next to the marble, there is our compass from Honeywell. Down beneath are the infrared sensors that you would have seen function had I properly remembered to bring the IR beacon. And then the ultrasonic rangefinder that you can use to figure out your altitude. That's that particular setup. Now the inside of basically experience the same of our custom hardware, which is there's a lot of similarities. You'll see the XP modem in there as well, and then other bits you'll see. There's the door cord, which is the Arduino processor that we're using for this one. Next to it you'll see a motor controller. This is a below-loop kick controller, which is a pretty powerful motor controller, capable of putting out about an amp per motor, which when you're dealing with this size, it's a fair amount of thrust. The last little bit of hardware I'm going to show you is the Norris unit itself, which is also programmed using Ruby. Basically, we have an LCD screen that gives us a readout of our battery information and any other sensor information we want to pump through there. The 9 volts powering the setup. Its own XP over here, and the door cord, which is the Arduino platform that this is running. Also, we have a little adapter so we can use our nunchuck to control it.
All right.
And that's the hardware.
Thanks, Damon. So let's go back to our presentation here. All right. So what can you actually do with a flying robotic blimp? I'm sure you're kind of wondering that. Well, you can make a paparazzi blimp. You saw our camera before. That's a very inexpensive, not very good camera, but you could put much higher quality cameras, aerial photography or aerial surveillance.
I have a friend that's a private investigator, and he wants me to build one that's disguised as some runaway party balloons.
Or an enviro blimp. You could connect environmental sensors. We actually have a small collection of CO2 sensors, carbon monoxide, natural gas sensors. Much safer to send in a robot than a human.
The virtual canary, very high-tech, spiffy, shiny canary.
And disaster preparedness and recovery.
One thing you can use with these things, the XP modems that we use are not only capable of point-to-point communication like we're using them, but they're also inherently a mesh networking platform. So in an area where all the communications have been cut off, potentially a fleet of these things could go in, establish a mesh network, connect to one thing that has internet way on the edge of the destroyed city, and suddenly everybody has connectivity. People can tweet what they're saying, tweet their locations, communicate.
But it's not all work. There's some fun and games too. This is a radio-controlled tank built by the Bay Area Tankers, which is an enthusiast society that had an amazing exhibit at the Maker Faire earlier this year. Maker Faire? Anybody? All right. So they use a kind of infrared laser tag to battle each other. And when we saw this at the Maker Faire, we looked at each other and we said, airstrike. And last but not least, the final frontier.
Blimps
in space! This is a real photograph taken from a weather balloon launched by a team of high school students in Spain earlier this year. So it can be done. There have probably been about 3 or 4 of these since then. The latest was a less than $200 weather balloon that took a picture from about 20 miles up. But the thing that all of these have in common is the search for the camera. They're like, can we make it to the GPS before the battery dies? We think we should just fly it back to HQ. So now, ladies and gentlemen, we continue the announcement that we made at Future Ruby in Canada earlier this year, the formation of the first Ruby Squadron. That's right. We need a few good primates to join us. No, we're serious, actually. We are quite serious right now. We're actually looking for 2 volunteers from our studio audience who want to come up here and race blimps. There is a prize. The winner gets a Blimpduino kit and a pair of XP modem adapters that were contributed by our sponsors DIY Drones and SparkFun. So two people who are ready to come up here right now and fly blimps? Who? Oh, all right. Well, come on. These are the most aggressive pilots in the room, apparently. All right, so look, we're going to get you guys set up with those Norris units. We have 2 of them, 1 for each of you guys.
All right, here's that. Hold on that for a second.
Now, you're red. You're red team. You'll be green team. He's Sith. You're Jedi. Any questions?
Something you need to know about the controls on these things, hold that in one hand there, and is that because of the rotation of the motors, since we weren't able to find a counter-rotating pair, if you go full throttle, it'll tend to pull in one direction, so short control bursts is what you're after. So basically what we're going to try and do for this race here, I'll take your guys' limits off your hands.
Take them down to the other end of the course.
All right, okay.
If you please.
Basically, what we're going to have you guys do is start from here, and your goal is to hit the far wall. Try not to hit the light.
Oh, this is, did you guys show them the throttle?
Yeah.
Okay, very important. The big button is forward, the little one reverse. Okay. The joystick controls all of your directional thrusters. This indicates your current display, all systems go. This is showing your current battery. If you go below 6 volts, you're out of the race, and you have to buy us new batteries.
Okay.
All right, hang on a second, guys. We actually have some theme music that we've picked out for this race.
Standing there alone, the ship is waiting, all systems are go. Are you sure?
You have to thrust.
Control is not convinced, but the computer has the evidence. No need to abort.
Short control burst.
The countdown starts. Watching in a trance, the crew is certain, nothing left to chance.
Give him my hand. Give him my
Always
hand.
working, trying to relax. Up in the capsule, sent me up a drink. Jokes
Right, you have to have the
major
throttle on,
time.
have the fun.
The count goes on. 4, 3, 2, 1. Earth below us, 15 falling, floating waiters, calling, calling.
Oh yeah! Oh yeah! Okay, now you just gotta make it back. Now you just gotta make it back. It's a round trip. It's a course.
Second stage is cut. We're now in orbit. Stabilizers up. Running perfect. Starting to collect. Requested data. What will it affect when all is done? Thinks Major Tom. Back at ground control. There is a problem. Go to rocket school. Not responding. Hello, Major Tom. Are you receiving? Turn the thrusters on. We're standing by. There's no reply. 4, 3, 2, 1. Earth below us. 15 falling.
I think we have a winner! All right, well, we have good news and good news. First of all, we just want to say a big round of applause for these 2 brave test pilots. I'm sorry, what's your name? Eli and Mark. Now, Mark, as the winner of our race, you are the recipient of one of these Blimpduino kits. Let's bring up our corporate logos.
Some soldering required.
A fair amount of soldering required. But the good news here is we're not going to let you go home empty-handed. You are also the winner of an identical Blimpduino kit.
You clearly need to practice.
Well, the controllers, on the other hand, these are ours. Here, you want to? Whoa!
Also, during the break, we're going to be trying to fly some of these around in the big courtyard outside, so see if we can pull it off.
So the future. What are the future of flying robots? Well, we have done quite a lot already this year. We started out with just a completely hacked-together prototype using a dork board. Since then, DIY Drones came out with their Arduino kit, so we have full hardware support for that. There's also another autopilot that's known as the RUBYCONF, which is really designed more for more sophisticated flying vehicles, which we are also working on. Currently, we're working on a hybrid lift vehicle of our own, which will use an RUBYCONF for control. And then one of the other interesting things that we are getting ready to do is to release some kits of our own, in addition to the directions that we're providing. That way, it's a lot easier to get started. One thing we've...
The Bay Area Tankers inspire us a lot, so we're going to start working on our own laser tag kit. They'll be able to mate directly with the Arduino hardware, which is already available.
Also, if there's any corporate sponsors who want to buy us a high-altitude envelope, talk to me later. So thank you very much. For more info, flyingrobo.com. You can also check out my blog at Dead Programmer Society. I am at Dead Program on Twitter, and this is at Damon Evans on Twitter. So
Thank you very much, everybody.
Thank you.